question 1, they want to know which graph represents the solution of this inequality. So if we want, we could get this into y equals, so I'm just going to rewrite it over here. So we have 9 minus 3y is greater than or equal to negative 6x. So we want to get y by itself. So what I'm going to do is subtract 9 for both sides. Negative 3y, these cancel out, is greater than or equal to negative 6x minus 9. Now we need to get still our y by itself, so I'm going to divide by a negative 3 cross on everything. When I divide by a negative 3, these cancel out, and I'm going to have y. Now I divided by a negative, so I need to make sure that I flip this sign, because when you divide by a negative, you flip your sign to have less than or equal to. This is going to be a 2x plus 3. So negative divided by a negative is a positive. So if I look at all of my graphs, they do all have this y-intercept of 3 and the slope of a positive 2 over 1. So now I need to see which graph is correct. The first thing that you should do is look at them, and you see that you have an less than or equal to, so you know that you need to have a solid line. So we can get rid of choice 2 and choice 4 because those have dashed lines. Now to see which graph it is going to be, we can test the point 0, 0. So if I test the point 0, 0, I'm going to have 0, is that less than or equal to 2 times 0 plus 3? 0 is less than or equal to 0 plus 3. Is 0 less than or equal to 3? Yes, that is a true statement. So that means 0, 0 is in the solution. So if we look, here's point 0, 0, here's point 0, 0. Which one has 0, 0 in our solution? That would be choice 1. This question, if you also wanted to, you could have plugged in 0, 0 in the original equation, just to double check to make sure that you solved correctly, and remember to flip your sign. Okay, so for number 2, they want to know which inequality is represented by the accompanying graph. Well, again, I have a dotted line, so I know that I can get rid of choice 3 and 4, because that has an or equals to. And then this graph is including point 0, 0. So I can test that point, and I want that to be true. So here, if I plug into option 1, I'm going to have 0 is greater than 3. Is 0 greater than 3? No. So let's check for choice 2. 0 is less than 3. Is 0 less than 3? Yes, that is correct. So choice 2 is our answer. So for number 3, they're giving us a graph, and they want us to find the equation. So what I would start doing is our inequality. If we wanted to look at this graph, we want to first start to write our inequality. So it's going to be in the form of y. We're going to have one of our inequality symbols, and then we're going to have an mx plus b, because it is a linear inequality. So if we look, our y-intercept is 0, so we're really not going to have a b, because that's going to be a 0. And if we look at our slope, we're going up to and over 3. So this is going to be y. We're not sure what our symbol is, but we know we're going to have 2 over 3x. So in order to find what inequality symbol that is, well, I can narrow it down. I know it's either going to be less than or greater than, because I have a dashed line. But to test which one it is, we can pick a point. So I'm going to pick the point 26, which is right here. And we can plug that in and see if that is true. So if I plug in my point 26, I'm going to have 6. And what you want to do is just pick a symbol and see if it's true. If it's false, then you're going to have the other symbol. So I'm going to try greater than 2 over 3, and my x is 2. So is 6 greater than 4 over 3? Yes, that is a true statement. So I am going to be using that point, since that point now is included in our shading. So it is greater than. Now, if we look at our choices, this is not here in our choices, so we're going to need to get these into getting the y by itself with the inequality. So if we try each one, ahead and got them all to get y by itself. And if we look at our choices, choice 4 is actually our answer because it matches up with the inequality that we said represents this graph. So for number 4, they want to know which ordered pair is not in the solution set of these two inequalities. So what we would need to do is take all of these points and substitute them into the inequalities and make sure that it is true for each inequality. So when we look at all of these, again, we want one that satisfies. If it satisfies both inequalities, then it is a solution. So we want to find one that did not satisfy both inequalities. So that would be choice 2. For question 5, they want to know what is one point that lies in the solution set of the inequalities that are graphed. So when we graph inequalities, again, our solution set is where the two inequalities cross. So I'm going to highlight that. So we're looking for something that is in this solution. Again, we want to recall that if it falls on a solid line that is next to that solution set that is included, but on a dashed line that would not be included because our dashed lines are not included in the solution set. It's just greater than or less than. So if we look at these points, 7, 0, 1, 2, 3, 4, 5, 6, 7, 0 would be, that would be right there, and that does actually fall in our solution set, so choice 1 is our answer. But if we look at our other ones, 3, 0, 1, 2, 3, 0 is right where they cross. And again, this is not a solution because this line is dashed, so that means that that is not included, so that cannot be a solution. If we look at our other one, 0, 7, 1, 2, 3, 4, 5, 6, 7 is up here, and that is not included because that is not in that double shaded area. That's just on one of our lines. And our fourth option is -3, 5, which is where none of our inequalities are represented there. So choice 1 would be our answer. Number 6 asks us what the x-intercept of the graph is. So if we look at our x and y axes, if you think about this, your x-intercept, this is your x-axis, this is your y-axis. Your x-intercept means it has to be somewhere on this x-axis. So what would our y value be if we were on this line? Our y value would be 0. So when they want us to find the x-intercept, that's going to be when y is 0. So what we want to do is take this equation and plug in 0 for y. So 4x plus 2 times 0 equals 12. 2 times 0 is just 0, so 4x equals 12. Divide by 4 on both sides, and we're going to get that x equals 3. So your y-intercept, your x-intercept is when x is 3. So that is the algebraic way that we can do this. If you weren't sure that the x-intercept is when y is 0, we could have put this into our y equals form and then kind of graphed it. So I went ahead and put our equation into y equals form. That way I can look at my graph. I put it in my calculator in that y equals and hit graph, and this is what our graph of this equation looks like. They want to know what our x-intercept is. Again, this is our x-axis, this is our y-axis, and we can see that we're crossing that x-axis, or our x-intercept is actually 3. So that is choice 3. For number 7, it says to watch a varsity basketball game, spectators must buy a ticket at the door. The cost of an adult ticket is $3, and the cost of a student ticket is $1.50. If the number of adult tickets sold is represented by A, and student tickets sold is represented by S, which expression represents the amount of money collected at the door from the ticket sales? Well, they're telling you that each adult ticket, which is represented by A, is $3. So to find out how much money we made from adult tickets, we're going to take that $3 and multiply it by A. Same thing for the student tickets. If student tickets are $1.50 each, we're going to take how much our student tickets are, which is $1.50, and multiply that by S, which is representing our student tickets. Now, if we want to know our total number of sales, our total amount of money collected, we're going to take these two and add them to find the total. So our answer to this would be choice 3. Number 8, they're telling you that Rowan has $50 in a savings jar and is putting $5 every week. Jonah has $10 in his own jar and is putting in $15 every week. Each of them plots his progress on a graph with time on the horizontal axis and amount in the jar on their vertical axis. Which statement about their graphs is true? So in order to make a statement about their graphs, I need to write an equation and maybe even look at their graphs so that I know what they look like. So if we look at Rowan, he started with $50 and every week he's putting in 5. So if we want to write an equation, that would be y equals 5x, that would be our slope, what he's putting in every week, and his initial amount was 50. If we want to look at Jonah, he's putting in $15 every week, so that's going to be 15x, and he started with $10. So if we look at the graphs of these two equations, we see since we do have different slopes, 15x and 5x, these do not have the same slope, so they're not parallel. So one graph cannot always lie above the other because they have different slopes. Eventually, if lines are not parallel, they are going to cross. So we can get rid of choices 2 and 4. Now, if we want to see which one has a steeper slope, we can look at the equation and look at the slopes. A steeper slope, if you think about it like climbing up a mountain, a steeper slope has a higher increase than a slope that is less steep. So a steeper slope in this case would be 15 because that number is higher. We're going up 15 and over 1 as opposed to up only 5 and over 1. So if we look at our graphs also, that could help us. If we look, we can see that Jonah's graph is steeper, this red one, than Rowan's graph. So our choice would be choice 3. The Jonah's graph has a steeper slope than Rowan's. Number 9, they're saying that a formula for calculating velocity is v equals 1/2 at squared. What is a expressed in terms of v and t? So they want us to get a by itself. So if we rewrite this, v equals 1/2 at squared. And I'm going to circle a because I want to get a by itself. So in order to get a by itself, I want to first get rid of this 1/2. So in order to get rid of that 1/2, I'm going to multiply by its reciprocal, which is just 2, and I'm going to do that on both sides. So I have 2v equals a t squared. Now again, I want to get this a by itself. I always want to ask myself, how are these attached? These two terms are attached by multiplication. So to undo multiplication, I am going to do division. And what I want to get rid of is that t squared. So I'm going to divide by t squared on both sides. On my right-hand side, I'm going to have a equals. And on my left-hand side, I'm going to keep this 2v divided by t squared. So I can't actually do that division. So if I look at my choices, this is going to be choice 2. Number 10 says that someone's looking for a new gym to join. Biceps R Us charges $70, one-time membership fee, and a monthly charge of $10. Deltoids Inc. will charge him a one-time membership fee of $25, but he will have to pay $25 per month. And for how many months will the gyms cost the same? So if they're costing the same, we want to take our two equations and set them equal to each other to see when they will have that same effect. So Biceps R Us is a $70 one-time membership fee, so that is our y-intercept. and it was a monthly charge of $10. So that's going to be 10x, that's our slope, monthly charge of $10, plus a one-time fee of $7. And we want to see when that is equal to, our other one has a one-time membership fee of only $25, but he has to pay $25 a month. So 25x, which is our slope, and plus 25. Now, in order to solve this, we need to get x by itself, so I'm going to subtract 10x on both sides. And then I'm going to subtract 25 on both sides. I'm going to have 15x is equal to 45. Again, to get x by itself, I need to divide by 15, and I'm going to get that x equals 3. So these two gyms will cost the same amount after 3 months. So if your choice is 3 months, is choice 3. For number 11, they're getting 4 different expressions, and they want us to identify which ones are going to result in irrational numbers. So I took each of these expressions and put them into my calculator to check. For the first one, I get negative 1 over 4, which is a rational number, is written as a fraction of integers. So this is rational. Our second one, if we look, we had a repeating non-terminating decimal. Again, our calculator can only write so many points, but there's no pattern. It's not terminating, so this second choice is irrational. Our third choice, when I multiply radical 5 and radical 5, I end up with 5. So this one is also rational. And 3 times the square root of radical 49 is 21, which again is a rational number. So they want to know which one's represented in an irrational number. So your answer is choice 1, which is this one only, option 2 only. Okay, so for number 12, the teacher asked the class to solve the equation, and Robert wrote this as his first step. And we want to know which property he used. Well, if I look, how did I get this 3x and this 6? What he did was he took this 3 and he multiplied it in what we call that is distributing. So the 3 times x is going to give us a 3x. The 3 times 2 is going to give us a 26. We keep that 21 using the distributive property. So that is choice 3. Question 13, they asked which the relation defined by the set of ordered pairs, which is given to us. They're saying this is not a function. They want to know which ordered pair, if we omitted it, so if we took it out of this, would make the resulting set a function. So remember, think of the definition of a function. For every x value, or for every input, there should only be one y value, one output. The problem here is that we have this point 0, 2, and we have this point 0, negative 1. So for this input of 0, we have 2 different outputs, 2 and negative 1. So if we omit this choice, negative 2, 2, that's not going to help our problem. We still have that this is not a function. So that's not our answer. If we omit 1, 4, again, we're still going to have those 2 inputs per 1 output. That is not our answer. For 1, same problem. Those did not get rid of any of our 2 inputs for a different output, so that's not it. Our answer would be choice 4. If we omitted this one, this relation then would be a function. Your answer is choice 4. Question 14, they want to know what the slope of the line passing through these 2 points are. To remember, our slope equation is our change of y, or y2 minus y1 over the change of x, so x2 minus x1. So if I put in these points to our equation, if I start with this y, if I have 6 minus this y, which is 4, I want to divide that by my x's. So again, I started with the 6. I need to start with my 3, and then subtract my other x, which is negative 2. If I I do that, I am going to end up with 2 fifths, which is my answer, and that is my slope. For 15, they want us on the axis below, graph this inequality. In order to graph it, we need to get it into y form, so I'm going to rewrite this. I want to get y by itself, so I'm going to subtract this 2x, and I end up with the inequality of y is greater than negative 2x plus 1. So if I want to graph this, I'm going to start at my y-intercept, which is 1. And my slope is negative 2 over 1. So I should make sure that my line is decreasing, so I'm going to go down 2 over 1, down 2 over 1. Continue. If I wanted, I could also go up 2 and left 1. Now, in order to draw our line, we need to look that I have a symbol that is just greater than here. So when I graph this, I need to make sure that I am using a dashed line. So if I draw my dashed line on, now the next thing we need to do is figure out our shading. So in order to figure out our shading, we should take a point and test it. So I'm going to test the point 0, 0. And we should plug this into our original equation, just in case we made an error solving it. So I have 2 times 0 plus 0. Is that greater than 1? Well, 2 times 0 is 0, plus 0 is 0 greater than 1. That is false. So since this is false, we are not going to include that point 0, 0. So that point 0, 0 is right here, and I do not want to include it, so I'm going to shade away from that point. So my shading is going to go this way, away from that point 0, 0. Now, the only other things that we want to make sure we do is make sure that we have arrows on the end of our dashed line, and we want to label this line with the equation. So 2x plus y is greater than. Now, they did X as a follow-up point. They want to know, is the point 1, negative 1 a solution? So if we go, the point 1, negative 1, over 1, goes down 1, is right there. And that actually falls right on our line. Well, since this is a dashed line, that means that the points on the line are not included. So we're going to say no. And if we want to justify, well, our graph kind of is justifying it because it is on that dotted line. But if we did want to substitute in this point to the inequality, we'd have 2 times 1 plus negative 1. And we're going to say, is that greater than 1? And we're going to get that 1 is greater than 1. Is 1 greater than 1? No, that is false. So this is not a solution to the inequality that we just put. So a student is studying the fuel efficiency of cars for a science fair project. He comes up with the following linear model, where W is the weight of the car in pounds, and M is the fuel efficiency in miles per gallon. For the first part of this, they want us to find the fuel efficiency when the weight of the car is 3,000 pounds. So they're giving us the weight of the car, so we want to substitute in for the weight of the car. So we're going to find M of our weight is 3,000, which is what they're telling us. So we're going to do 56 minus 3,000 divided by 120. And when we substitute that in, we would get a value of 30. So the fuel efficiency of this, would be 31 miles per gallon. Now for the second part, they're asking us to find the weight of the car when the fuel efficiency is 21 miles per gallon. So they're giving us the fuel efficiency. In our equation, our total fuel efficiency is represented by this M of W. So they're telling me M of W is 21. So in order to solve that, I'm going to have 21 equals 56 minus W over 120. And I do want to solve and get W by itself, so I am going to subtract this 56. And I am going to have negative 35 equals negative W over 120. I want to get rid of that negative 120, so I am going to multiply by a negative 120 on both sides. And my final answer when I do that is that W is going to be 4,002. Like, wait, if I wanted the fuel efficiency to be 21 miles per gallon, it's going to be 4,200 pounds. So Sarah works 2 jobs, as a hostess at a local restaurant and the other as a teller at a local bank. She earns an hourly wage of $8.25 at the restaurant and $10.50 per hour at the bank. Sarah needs to earn a combined total of no less than $400 working both jobs in 1 week to purchase the iPhone 6. We want to write an algebraic inequality to represent the possible number of hours Sarah would need to work both the restaurant, which they're telling you is R, so if I want I put an R here to represent my restaurant, and the bank, which they are telling you is B, so that we can purchase this iPhone. So if I want to write an inequality, well, she's making $8.50 at the restaurant, so I'm going to put my $8.25. $8.25 is how much she's working at the restaurant, and I'm going to add that to how much she makes working at the bank, which is $10.50. Now, the part we need to be careful about is they're saying we're making no less than $400. So if I think about that, $400, if I want to make no less than that, that's the minimum amount I want to make. So I want to make money that is more than that. So since I want to make money that is greater than $400, the symbol that I'm going to use is greater to, and I can make $400, so that's why it's going to be greater than or equal to that 400. Now they ask a follow-up question. If she works 15 hours at the restaurant, they're telling you how much she worked at the restaurant. Use your inequalities to determine the minimum number of full hours she will need to work at the bank to reach her goal. So they're telling you at the restaurant she worked 15 hours. So we can substitute that in for our variable of R. So we're going to have 825 times that 15 hours that she's working there. Sorry, I'm just noticing I did not put a B there. We do need a B there to represent the number of hours she's at the bank. So that would be the correct inequality. Sorry. So now when we're writing this, this should be 1050 B, and that's greater than or equal to 400. Now we just need to solve this. This is going to be 123.75 plus 1050 B. Again, we want to get B by itself, so I'm going to subtract this from both sides. Cancel out, and I'm going to be left with 276.25, and to divide by that 1050 on both sides. I would get that B is greater than or equal to 26.3095238. And again, I want to write out that entire calculator readout. I cannot round unless they ask me to round, and I can put a dot to symbolize that this is an irrational number and it is going on forever. Now, if I look again at my question, they want to know how many full hours she would need to work at the bank to reach her goal. So this is not representing how many full hours. So in order to make that exact total, if I look at this on a number line, this would be where my 26.309 that is, and I would have to have any values greater So I would not be able to say 26 hours because she would not quite reach her goal. So I would need to round up to 27 hours, which is our answer. For number 18, I want to solve for x. So what I'm going to do to get rid of that 4/7 that is being multiplied in is I'm going to multiply by 7 over 4 on both sides. When I do that, I'm going to be left with this x plus 14 over 20, and that is going to equal 35. Now I want to get x by itself, so I need to subtract this 14 over 20. And I'm going to get in my calculator, if I try to do this with my alpha y equals, I would get x equals 343 over 10. If you did get it as a decimal, you should also have that x equals 34.3. So either one of these answers will be accepted. 19, they're telling us that a student babysits for X hours a week at a job that pays $4 an hour. She has accepted a job that pays $8 an hour as a library assistant, working Y hours a week. She will work both jobs. She's able to work no more than $15 an hour a week due to school commitments. So that's another important thing that we would want to underline. And Edith wants to earn at least $80 a week, working a combination of both jobs. They want us to write a system of inequalities that can be reused to represent this situation. So the first thing I'm seeing is that she's able to work no more than 15 hours. Well, if we look at what is telling us how many hours she's working at each job, X is how many hours at the one, and Y is how many hours at our other job. So if I add those total number of hours, X and Y, I want that to be no more than 15. So 15 is my max, so I want something that is less than or equal to 15. My second equation, they're telling me she wants to earn at least $80 a week. Well, we have to write, my second inequality. If I want to write an inequality to represent this, I need to see how much she's making for each job. So our $4 is going with our first job, because she gets $4 an hour. And our second job is a library, she's getting $8 an hour. So if we add that 4x and $8 an hour for that second job, and they're telling us she wants to earn at least $80 a week. So at least $80, that's going to be, she wants to make something more than that, so that has to be greater than or equal to that $80. Now, in order to be able to graph these on our graph here, we're going to need to get them into y equals 4. So we're going to subtract our x. This is going to be y is less than or equal to negative x plus 15. So that's one inequality that we want to graph. Our second inequality, I need to subtract my 4x on both sides. So I'm going to have y is greater than or equal to negative 4x plus 80. And then divide by 8 on both sides. And my equation is going to be y, so my inequality is greater than or equal to negative 1/2 x plus 10. So these are the two inequalities that I would like to graph. We want to graph them accurately. So I went ahead and graphed both of these lines on our graph. And now the only other thing that we need to make sure that we do is that we make sure that we do our shading correctly. So for our green line, we had a y-intercept of 10, and I went down 1 and over 2 for negative 1/2 slope. And for my red line, I had a y-intercept of 15, so I started at 15, and I had a slope of negative 1, so I went down 1 over 1. Now I needed solid lines because our symbols were less than or equal to and greater than or equal to, so we needed to make sure that we had. So to do our shading, I'm going to test this point 0, 0, which is down here, to see if that is a solution or not. Again, I'm going to test it to my original inequalities so that I know I didn't make any errors solving them. So on my first one, if I have 0 plus 0, is that less than or equal to 15? 0 is less than or equal to 15. So in my red one, I am going to include that 0.00. So let's use this for my red one. I'm going to include that. Actually, to show that we are including all of these numbers. So on my second one, let's test this point. Again, into our original 4 times 0 plus 8 times 0. Is that greater than or equal to 80? So I have 0 plus 0. Is 0 greater than or equal to 80? That is false, so that means I'm not going to include that point. So again, on this green line, I'm not including 0, 0, so I'm going to shade away. Shade up, going this way again, away from that point, 0, 0. Now, to see where my solution is where our two inequalities overlap. So my solution set is going to be any points represented here. Now, there was a follow-up question. They wanted you to determine and state one combination of hours that will allow her to earn at least $80 per hour while working no more than 15 hours. So we want to satisfy both these inequalities. So to answer this, we could have picked any point that is within this solution set. So I'm going to pick this point right here. Let's go over 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I know that's definitely there, so I'm going to pick the point 2, 11. If you wanted to, you could plug that into both inequalities and make sure that that does